Alright, so what we're going to do today, on the calendar, if you saw on the calendar, it showed product rule and then like exponential and logarithmic. I'm going to change it up just a little bit. I'm going to put the product rule and the quotient rule together. So between today's notes and next day's notes, and yes, the calendar will be fixed and cleared, and you'll be able to understand it a lot clearer, let's say by the end of tonight. I'm going to mix all the next 2 days together, but in different order. Here we go. So the graph of a position function is shown, and we're going to sketch the velocity function. Can someone tell me what is the velocity on this position function at 0? So at x is equal to 0, it's actually undefined. Because we know that the slope, i.e. the derivative, is undefined at cusps. You with me? But it's also undefined at an endpoint, because endpoints are non-differentiable. Endpoints need something that we've talked about called local linearity. Means it needs to be slow and smooth changing, not a cusp or a drastic change. But at the same time, to find a derivative, you must have, at a point, you must have local linearity, meaning there's stuff to the left and there's stuff to the right. Almost think of it like two-sided limits, or both one-sided limits. Okay? So we know that it's undefined. Okay, so let me ask you this. Between 0 and 4, what's the slope? 3/2. Up 3/2. So we'll say 1/2. Okay? So what I'm going to do is I'm going to show 1.5 from 0 to 4. Do you see how this is horizontal? Because my slope is constant right here. Okay? And then someone tell me, from 4 to 7, what's my slope? 0. So over here I'm going to have open to open at 0. And because it's a cusp, both of them would be open. Okay? And then finally, from 7 to 9, what's the slope? 1/2. So we'll have open here and open there. Does that make sense? I just want to show endpoints and cusps, and also what the function of velocity looks like graphed out compared to its position.
And you have to put the open circles on endpoints too.
You do, because it's non-differentiable, because you need local linearity. You need both one-sidedness. So forevermore, endpoints, the derivative is undefined. Does that make sense? Just like a derivative at a cusp is undefined. All right. So let's go to product rule. Okay, guys. So let me break it down what we're doing. If I want you to find the derivative of this function, and we did it old school using this equation, the definition of the derivative. You don't have to copy this. But if we were doing it that way, we would look at this equation. Don't write this down, please. We would look at this and say this is x plus h, x plus h, x plus h. And all this that we just did would just be this piece right here. We would still have to minus all of the f of x, put it all over h, and approach 0. And that would be a nightmare. But we don't have to do that, because brilliant mathematicians from before have passed down rules of differentiation that we just have to follow the rule. So if we see a product a multiplication problem between two functions. And my two functions are, the first one is f, the second one is g. And whatever they are, like here, I could say the first one is f, and the second function that's multiplying is g. Notice that they are multiplying in between. So now I can go to product rule. Okay, here we go. Here's the rule. The first times the derivative of the second. Notice how I did that? G prime. Okay, plus the second times the derivative of the first. So guys, instead of doing all that work by definition of the derivative, all I have to do for this product is follow this rule. Okay, so let's go ahead and do that. So here we go. Y prime is equal to the first times the derivative of the second. Can you tell me what the derivative of the second is right here? 4. Plus the second in its normal state times the derivative of the first. What's the derivative of the first, guys? Negative 4x plus 3, but let's keep it in the order. Just 3 minus, yeah. Right now, this is my answer.
That should be
Why is it being
4x
squared?
Oh, my bad, no squared. Thank you for catching that. Right now, this is my answer. Non-simplified, this is my answer. Okay? We're going to practice a lot of algebra. A lot of algebra. A lot of simplification will make or break you in this unit for sure. You just did, listen, you just did the calculus. The rest is all algebra 2. Okay? Yes?
Didn't you first simplify and then do the
Okay.
derivative?
He's saying it, and this y'all's, your attention to stuff is awesome. Usually I have to try to warn people of all these things, and you just see it already. So, listen. Could you, the way Omar is saying, could you have just FOILed this out and then just done power rule? So first outside, inside, last, and then power ruled everything? Yeah. But there's not one way to do, there's not only one way to derive. What you do will be different from what you do, will be different from what you do, but ultimately we end up at the same answer. And here someone asked me earlier, which one's the easier way? Well, it depends on you. It depends on what skills you have. You see what I'm saying? So you're going to be building this awareness of, I'm better at doing stuff like this, or I'm faster at stuff like this, but what do you need to make all that happen? Practice. You need a lot of practice. Okay, so we're going to be doing a lot of algebra, just FYI. Okay, so distributing this, we have 12x minus 8x squared. And distributing this, we have 15 minus 20x plus 12x minus 16x squared. I'm adding. So as of right now, is my answer still correct as written? It actually is still correct. On this level right here, there was something that I did that was so subtle that will make or break you going forward. What is it that I did to ensure that I don't make mistakes? Parentheses. The power of parentheses. And the most important parentheses that I made, let's see if you can guess it, would be where? Here. I think it's there. Can someone tell me why? Go ahead.
So you know how to distribute the sign.
Perfect. Because if that was a negative, then it's about to change all of these signs. And if you mess up there at the beginning, the rest is wrong. Okay? So I just wanted to bring attention to that because that's a very important and very common mistake. Do I need that parentheses though right here? Do I need to write this? Yes or no? No, because I have an addition. You with me? All right. So combining all like terms, what's the biggest power that you see? Okay, so we have y prime equals negative 24x squared. How many x's do you see?
Wait, there should be an x at the 12x minus x, 8x squared.
Oh, there should, okay, I don't know why I didn't write that there. But there should be a 12x here. So I have a negative 20. Those 12s become 24, so I get a positive 4. Okay? And I did not plan on missing this x, but here's a good example of we got to be a little careful. Okay? All right. What's my last number? Plus 15. So this right here, let's go back just a little bit, and let's do what Omar was suggesting. What if I distributed this first one? 15x plus 12x squared minus 10x squared minus 8x cubed. If I did that and I just did power rule, look at this. We see negative 24x squared. This would simplify to 2x squared, where this would become 4x. And then the derivative of that is just 15. So many different ways to do it. Do you derive first, or do you simplify and then derive? You will learn. It depends on what you're given, because there's not one way and set form that will work with everything easily. All right, let's find the derivative. To me, how would we start this?
Take out a
Okay, so someone, Christian is saying to GCF out. We could GCF out of 2. I'm gonna tell you let's not GCF out of 2 because I want to see what you do next. So if I don't GCF out of 2, what could we do?
Do you use any of those rules, like when you're saying like the derivative of sine of x?
Yeah, for sure. So the thing that I would say is power of parentheses is very big, but at the same time, see, when I do parentheses, it can show me what rules are there. Right here, I see this huge product between 2x and cosine of x. So already I'm thinking product rule. So real quick, first times the derivative of the second plus the second times the derivative of the first. And all we did was this piece. Whoops. All we did was that piece right there. We still have to do this piece here. And yes, I can pull out a 2, constant multiple rule-wise, and just say, what's the derivative of sine? Cosine. And if I throw that negative 2 back in, it would be negative 2 times what I got as far as the derivative of sine. So this right now is my y prime. How many terms do you see up here? 3. Nice. And the faster that you can identify this, look how fast he just identified it, you're going to be able to derive faster than other people. Because it's how organized is your work. So there's one term, there's one term, there's one term. On the first term that I wrote, what's the most important thing that you think that I need to, that I should have written down the way I did? The negative, yep, but more so that. Because if I didn't write that parentheses, I would have something that looked like this. And that's not the same as negative 2x sine of x. If I don't put parentheses, this looks like 2x minus sine of x. And that's totally different. So power parentheses. Plus 2 cosine, minus 2 cosine. So that goes to 0. And I'm left with the derivative is negative 2x sine of x. Okay? All right, so now that we've done product rule, let's do quotient rule. Now, quotient rule is when I have two functions that look like a rational function. I'm dividing by something. Okay? So let's look over here. F of x I have as sine of x. G of x is here. And again, brilliant mathematicians came up with this rule that would help us prevent from doing all that work. And we could get there a lot faster. Okay? And the rule is this. The bottom is g of x. We're going to multiply it with the top's derivative. Then we're going to subtract the original top, multiplying it by the bottom's derivative. All over the bottom squared. Let me help you out.
Just the bottom, not the derivative of the bottom.
Just the bottom, not the derivative of the bottom, is correct. So some people do it like this too. Let's say I had u and v, and I wanted to find the derivative. Okay? It would be something that looks like this. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. A lot less to look at. Or we can pass down weird shortcuts even further of memorization. Let's call the top high and the bottom, the lower function, we'll call it low. So here we go. This would be low d high minus high d low over low low. That's weird, I know. But low d high minus high d low over low low. I think you'll remember that more than g of x, f prime of x, you know what I mean, and stuff like that. So whatever you need to, do y'all know who Pee Wee Herman is? That might be before y'all's time. Yeah, that's way before y'all's time. Anyway, so low d high, there's a thing that he used to do on his show, whatever, it was a kid's TV show, but he'd go make it like a high, make a hiney ho, or whatever it was. So to me, this reminds me of that. Anyway, sorry, side note, I got distracted. Good?
Yeah.
All right, so here we go. Low, man, I'm getting old. My reference is no longer recognizable. Low d high minus high d low all over low low. And low low you can write it like this, or if you know that it's going to be x to the power of what? What does x cubed to the power of 2 become?
6.
X to the 6, right? Algebra 2. If you put x to the 5, we've got to review algebra 2. And already it's wrong. You know what I mean? So this would be x to the power of 6. Questions so far, guys?
Another question.
Yes.
Do you treat the bracket like a parenthesis?
Yes, you treat the bracket like a parenthesis. Yes. And I only do that because you're going to see your work. I'm not even kidding. Some of these problems will be about a good half page, maybe 3/4 page long with all the work that you do for one problem. Even though we're doing shortcuts.
What's like the difference between a D and a, two brackets versus like D over dx?
Okay, this is the good question. This right here is just like a parenthesis. But this over here is saying like the derivative of that top function. Okay? That's what, that D is like the derivative of the function. Okay? So if I did something like, what's the derivative of 2x, guys? 2. But what if I said 2x with brackets and it was squared? What would that be? No, just the 4x squared, just the way it's written. Okay? I just want to make sure that you understand. Alright, so now let's go over here back and we're going to simplify all this out. So our our calculus is done. And the rest is algebra 2. Alright, so here we go. So, algebraic manipulation and simplification is a nightmare depending on how strong your algebra 2 skills are right now. What could I cancel? And I'm going to say that as openly and generically as I can. What can you see in my running answer right here that I could cancel with the denominator the way I used to cancel h's with zeros? Remember that long ago when I would try to cancel the h? So not x cubed, you're close. It would have to be x squared because the biggest thing that they have in common is x squared. Okay? Do y'all see anything else that we could GCF out? Okay, so this is what we're going to do. We're going to GCF out an x squared, and everything else is left over inside. X cosine of x minus 3 sine of x. All over x to the 6th. Do y'all see what I did? Okay. So now, these will cancel. That'll change to a 4 because of algebra 2. And nothing else cancels. So that my last final simplified answer is going to be that. Now look, be careful, please. Because those of you who haven't mastered algebra 2 yet, I mean completely mastered, they will look at these x's and they will try to cancel. They will look at these x's and they would try to cancel. You with me? And the reason why they can't cancel those x's, you tell me, what's the reason why they can't?
They're part of the sine.
Perfect. Because it's not cosine times x. It's cosine of x. It's a function almost like this. It's not f times x, it's f of x. Go with me? And the same exact mistake sometimes happens on natural log of x. People have a tendency to try to cancel out this x, and now you have a natural log of what? You know what I mean? Because they don't understand where parentheses and multiplication. Parentheses, multiplication, and negatives. It's all about that a lot. And then fractional exponents, and you'll see that in just a bit. Questions?
Okay, so they can't cancel out those x's because they're part of the function, the cosine and sine. What about the other functions?
Okay, so what about, and this is a good question, why do we not cancel those out? I mean, we could. Watch, she's asking a really good question. Couldn't we do this? X cosine of x over x to the 4th minus 3 sine of x over x to the 4th? And then you could cancel this with one of these, and you could write as a final answer on a test something that could look like this. And you would get just as much credit as if someone who wrote this. You with me? And the reason why I want you to practice with all this manipulation is because on multiple choice, you have a 2-minute time limit average to get all these multiple choice questions on your AP exam done. And you're doing all this work, and it's even more than this, in 2 minutes, and you get faster, you'll see. But the thing is, this could have been A, and this could have been B. And maybe they put a plus here. So you did all your work. And you're like, man, mine looks exactly like that, only I have a minus. Maybe I made the negative mistake. Wrong. You know what I mean? So we got to know how to do algebraic manipulation so we can find the other forms that could and would be equivalent to the one that we just got. Do we understand?
So is A, that's the most common form?
No. I don't want you to think about it that way. That was just an example of the reason why I want you to know.
Sometimes we would have to
Yeah.
simplify to
Correct.
answer B.
So the forms that I give you, Omar, those are the ones that are most preferred. Okay? Preemptively, those are the ones that are most common as you put it. But don't dismiss that you need to know variations of that. And all you're doing is algebra. Alright, here we go. Next one. I have f of x is equal to the following, and I want to take its derivative. Any suggestions on where I should start? Brian.
That to the x to the negative 4 and then move it up so it's like x to the 6 on top.
Okay, here we go. Check this out. Write it off to the side. I think what Ryan is saying, could you change this to be that? With it multiplied. Is that mathematically correct? Yes or no? Yes, that is mathematically correct. Do we have any other suggestions? Because if I did this, Ryan, what would I do next? I could distribute. And I would get, Ryan, what would I get? So you just add those powers, or do you multiply? What do you do?
Oh wait, it was this parentheses. Do you multiply?
So here's the thing, guys. Listen. If you're distributing, you're multiplying these, what you're really doing is, let me show you the work, because some of us don't know. We would have x squared times x to the negative 1/4 plus 2 times x to the negative 1/4. So yes, you will add those. You with me? You're with me? So that's what? 8 over 4? So x to the 7/4.
Are we writing this down?
I think you shouldn't write it down. That's why I said don't. But I mean, you can if you want. What I'm trying to show you though is the choice of what you do will be different than what someone else does. Which one was the easier route and why? You with me? So now you could do power rule. It would be 7/4 x to the 3/4 minus 2/4, which is 1/2 x to the negative 5/4, which then you could write as 1 over 2 x to the positive 5/4, because we're not allowed to have negative powers, and we would get this as a final answer. To me, I steer students away from that, but they can still do it if they want. But the reason why I steer them away from that is because what these end up becoming as far as fractions, and they struggle a lot with fractions, but also because in the problems that are coming your way, I don't think you should bring this up and make it a negative. The only time I think you should do that is if the top numerator, what? Is one term and it's a constant. This already has 2 terms. I wouldn't do it. Only because you heard the confusion just now of what does that do. You know what I mean? As far as am I multiplying or adding those powers. So what I would do on this, here we go, is I would have written this as, first of all, this is the rewrite. And then I would have done quotient rule. Low d high minus high d low 1/4 x to the what? Negative 3/4 all over what? X to the 1/4 squared. So this is why I put those brackets here, just to help remind us also that visually that 1/4 and the 2 are going to do what? Add or multiply? Multiply to get 1/2. So x to the 2/4 reduces to x to the 1/2. Okay? Now, we're not allowed to have negative powers in our answer. Okay? And what I'm about to show you will help a lot of stuff right now. Okay? Here we go. Let's make some room. This right here is my numerator. Okay? And if I rewrote this, because of this negative power, I could write it as x to the 1/4 times 2x minus x squared plus 2 times 1 over 4x to the 3/4. Do you all see what's going on right now? Okay, so this times 2x minus that, and I'll get x to the 1/2. You with me? Alright, so now, what makes this weird and difficult, because I'm trying to simplify this, is this denominator right here. Do you see it? This denominator piece in the numerator. Say that with me. A denominator in the numerator. Isn't that weird? But this denominator in the numerator needs to be removed. It needs to be canceled. You with me? So here we go. We did this way back when we did limits. And I'm going to make it a lot easier for you because we were just doing algebra then. Is I'm going to multiply by a form of 1. That will cancel out this denominator in the numerator from not being there. You with me? So what's the form of 1? 4x to the 3/4 over 4x to the 3/4. Watch carefully. Okay? If I multiply this here, what did I just cancel? I canceled this with this to a form of 1. I still have all of this left over, which is x squared plus 2. You with me? So let's write that off to the side way up here. X squared plus 2. Now watch. The reason why some of you have confused looks on your faces, how many terms did I just highlight just now? Oh, so 2, 1, which one is it?
1.
It's 1. Because it's all glued with multiplication. So it's like if I were to have 1 over 2x, and I multiplied, let's say, by x squared, I'm basically canceling out this, and I have something left over. It's that cancellation form of 1. So when I distribute, I'm left with x squared plus 2 in the top right. Okay, now here we go. How many terms do you see here that I just boxed? 1. So if I come over and I now distribute this over here, what is this going to turn into? Well, let's do it. 4 times 2 is 8. Do you agree? Do you see what I'm doing? So I'll get 8, because 4 times 2 is 8. And then I have x to the 1/4 and x to the 3/4. I'll write it over here. X to the 1/4 and x to the 3/4. I'm multiplying all those pieces together. So it'll be x squared. So this became 8x. Okay? So this simplified to 8x squared minus all of this. Let's see what the bottom becomes. Look at the bottom. Again, I'm multiplying by this form of 1. Can you tell me what those powers end up becoming?
No, sorry.
5/4. So it would become x to the 5/4.
4x.
Or 4x, thank you. 4x to the 5/4. Go with me? And if you need to go back and watch this video, please do so. Otherwise, trying to get a common denominator in the numerator, remember we did that way back when we did limits? I think it's a little bit more difficult. I actually like this form of 1 because it does it faster. Okay? And it simplifies clean. This is my running derivative answer. What's the most important thing? Ooh. What is the most important thing that I have written? Parentheses. Right here. because what I really have is 8x squared minus x squared minus 2 all over 4x to the 5/4. We can see what cancels or combines. We see that we have 7x squareds. Here we go. Can something cancel? Do you see something that can GCF from the top two that you can pull out, like GCF parentheses, that would be able to cancel with something from the bottom? No, there's nothing. There's nothing that they have greatest in common. So when you know that you can't, this would be your final answer.
Can you not simplify like the exponents more if you really wanted to?
So here we go. Could I simplify the exponents more? Can I do something like this right now, cancellation?
Yes. You would just
If I split them up, yes. So if you want to do that, you have to do it with both the 2 and the x squared. If you can't, you need to write it out as 7x squared over 4x to the 5/4 minus 2 over 4x to the 5/4. Then you can simplify those right there.
Of the 2 and the 4 cancel.
And yes, the 2 and the 4 could reduce to 1/2. But again, to each his own. We're all going to have different variable answers. I'm just trying to do the one that's most common on the multiple choice questions. Okay? So remember, it's been a while. We learned this. So, if in doubt, let me ask you this. From what we learned, can I cancel those? Yes, to 1/3 I can. Can I cancel these? Yes, to what? 2/3. Can I cancel these? No, I cannot. Okay? If you don't understand that, you're going to struggle with reducing. If you want to help yourself right now, I would break this up as we continue to try to do right now to see, oh, this would go to 1/3. And this will only cancel 1 if it's one term. If it's all glued together with multiplication, it will only cancel this, not both. If it was glued together with addition, then it would reduce both, because you're separating it out into 2 equations per se. Or 2 functions. You know what I mean. 2 pieces, 2 terms. Do you understand? Just trying to help you out with cancellations and reduce. Alright, so let's go to a couple things. First of all, watch. If you have a quotient in which the numerator is a constant, we've talked about this, it's easier to write this as 9/5 x to the negative 2. Notice that I just brought the x up. If it wanted me to bring up the 5 as well, it would have been written like this. Then this would have changed to that. But if it's not in parentheses, PEMDAS is saying only the exponent is done first. Power parentheses again. Do we know where parentheses belong and where and why and when?
Do you have to have the x to the negative second outside, or could you just do 9x to the negative second over 5?
You could do 9x to the negative second over 5 as well. Same thing. Okay? So now this will multiply and give me a negative 18/5 x to the negative 3, right? X to the negative 3. But I will give my final answer with no negative powers. So I would get 5x to the positive 3. Alright, a couple more. So what I'm going to show you are, we're done after this. So we have this slide to go to this table, and then we're done for today. The derivative of tangent. First of all, I know the derivative of sine. It's cosine. The derivative of cosine is negative sine. We're going to find out what the derivative of tangent is. We're also going to find out what the derivative of secant is. We're going to find the derivative of cosecant. And then we're going to find the derivative of cotangent. First of all, I'll tell you right now, all the cos, they're going to have a negative. The derivative of a co is always negative. The other ones are always positive. Okay? It's a good way to memorize it in your head. And you will have a quiz next class, so I want you to memorize these before we have next class. Okay? Here we go. So the derivative of tangent is the same as the derivative of sine over cosine. So now that I know the quotient rule, I could say low d high minus high d low. Notice the power parentheses over low squared. This is the derivative. Let's simplify the top. What do y'all see at the top? This is why we learn trig. What do y'all see at the top? I don't see cosine squared of x. What do you see on the...
2 cosine x.
I don't see 2 cosine x.
Oh,
I'm seeing if you can go further.
is it the,
I see there is cosine of x, but I'm trying to cosine squared of x. I want to see if you can go further. So you see cosine squared of x, no worries, plus, because there's 2 negatives, sine squared. What do y'all see? What is it? 1. I wanted to see if you could see 1. Okay? So all this is an identity that is 1. And it's going to be 1 over cosine squared. What's 1 over cosine? What's 1 over cosine? Secant. So what's 1 over cosine squared? Secant squared. So the derivative of tangent is secant squared. It's the same as this, but please don't write it like this. You will write it like that whenever you're using it for the calculator, but don't write it like that as a final answer. I want the final answer to be written like that. Secant is the same as 1 over cosine. And if I take the derivative, I have low d high, which is 0. So that zeroes out. It's gone. Minus high d low over low low. Remember, this zeroes out. It's gone. So what I'm left with is a positive sine of x. Check this out. You're going to freak out a little bit maybe over cosine squared. And you're probably asking, why did you write cosine squared like that? Because of practice and experience and seeing where this is going. What do y'all see here? Tangent. What do you see here? Secant. So the derivative of secant is secant x tangent x. Secant x times tangent x. Okay? So here we go. Let's fill it in. Secant x tangent of x. Tangent is secant squared. Cotangent is negative cosecant squared. And cosecant is negative cosecant cotangent. Because of the sake of time, I'm not going to show you the work on those other two. So a former student years ago, who's now a doctor, came up with this little chart that he just made, because that's just the way his brain worked. He just organized and workaholic. Here we go. He came up with this. Secant. Let me make it clear for you. This will help you memorize for next time. So secant, secant, tangent. And then he did cosecant, cosecant, cotangent. He made this little table. So he could memorize them fast. He knows these for sure. And he knows any co is going to be a negative. And then he went, I'll give him shouts out, his name is Devin Goulet, okay? He worked 30 hours as a manager at Sonic. While he did this, just pretty awesome student. And he came up with this, and I've been using it ever since. The derivative of secant is secant tangent, okay? the derivative of tangent is what? Secant squared. The derivative of cosecant, negative cosecant cotangent. And the derivative of cotangent is what? Negative cosecant squared. Hopefully that helped you, because you got to memorize it very quickly, okay? Know the 6 trigonometric function derivatives by the next time we meet. But are there any questions that you have for me right now? Practice, practice, practice. The homework is due on Tuesday. Okay? I'm going to give you another homework assignment that deals with this kind of stuff that will be due very soon as well. Please, please, I know it was a little bit of a relaxation of not that much homework over the weekend, but we do have to catch up a little bit right now. We're not behind. We're not. But we need to catch up with practice. Questions? Negative mistakes, parentheses mistakes, and algebra 2 fractional powers. Okay? Yes.
Is the quiz going to be over the trigonometric function?
Yes. So the quiz can include anything that we did today. Okay? So please make sure. Yes.
Is the quiz next class?
Yes. And that's going to be on paper.